Section 3.2, graphing linear models, unit analysis. All right, what's going to happen in this section is we're going to be given a real-life situation. And from the real-life situation, we're going to have to create an equation, and that's what a linear model will be. And we will use something called unit analysis to check to see if the equation we have created makes sense. All right, so here's an example. This is problem 5 on page 130. A person earns a starting salary of $24,000 at a company. Each year, she receives a $3,000 raise. Let S be the salary in thousands after she has worked at the company for T years. Part A asks us to fill out this table. So we have the time at the company, T, and the salary in thousands of dollars. So when time is 0, a person earns a starting salary of $24,000. So her starting salary would be $24,000. At the end of a year, she gets a raise. So she would have 24 plus, she would get an extra $3,000. That would be $27,000. At the end of year 2, she gets another raise. So there's a couple of different ways I could write this. I could write this as 27 plus 3, which of course would be 30. Or I'm going to write it this way instead, and we'll see why for a minute. This is her starting salary, 24, plus she gets $3,000 for 2 years. So that's 24 plus 6. That's also $30,000. Now I'm going to use that model, and we'll see why in the end when we get there. So year 3, she would make $24,000, her starting salary, plus she gets $3,000 for 3 years. So that's 24 plus 9, that's 33. And in year 4, she would have $24,000 for starting salary, plus she gets 3,000 times 4 years. So that's 24 plus 12, that's $36,000. And then they ask us, what's the formula for T years? Well, the formula for T years kind of follows this pattern. She starts at $24,000, and then she gets $3,000 for every year. Okay, and then it asks us to do Part B. Part B says, perform a unit analysis. All right, so what do we have? We have S. Here's our formula. S equals 24 plus 3 times T. So the S here on the left-hand side, that's salary. So this is money. So this is money. And what we need to make sure of is we look at our right-hand side, and we also have money. If our units are the same on left and right, there's a good chance we have our equation correct. If our units are different, then our equation is definitely wrong. So let's see, 24,000, 24, that was money. So that's fine. Plus the 3. What was the 3? Well, a lot of students would say 3 is money. She gets $3,000. Well, that's true, but it's not complete. She really gets $3,000 per year. So this 3 right here is really money per year. She gets $3,000 every year. This time right here, this is years. So think of years as being years over 1. And notice that year will cross out with year, and so we really do have money plus money. So on the left we have money, on the right we have money plus money. Now the mistake I will see students make a lot of times is they will tell me, this is the mistake, write that down so you know that. Students will give me the formula as S equals, maybe they'd write 24 plus 3. They'll write that as a formula. And by unit analysis, you should see that this is wrong, because this is money, this is money, but this is $3,000 per year. This is money per year. So you see, you don't have money on both sides. Okay, so that's what this unit analysis thing is about. It's a way to check your equation to see if you most likely have the correct equation. All right, what comes next? Part C, graph the equation by hand. Okay, part C, I'm going to draw a graph. I already have a table built, so that shouldn't be too bad. I need more room here, we'll see. Okay, we have, what do we have? We have our input is T, time, so there's T, and our output is S, money. So we have 1, 2, 3, 4, 5, 6 years, I guess. And then money, let's see. Our lowest one is 24, and it goes up each time. So I'm going to do something here that you'll see every now and then. I'm going to put some little slash marks right there. What that little slash marks means is I'm skipping some numbers because I'm not going to use them. Okay? Our lowest value is 24, and then it goes up. So I'm going to start right here at 24 and then go up. And I'm going to go up by threes because that's what my information does here. So I would have 27, 30, 33, 36, 39, so on and so forth. Okay? 24, 30, 36. I don't need to mark all of those, I suppose. All right, so I have time is 0, salary is 24, 0, 24. 127, that's going to be right there. 230, 333, and 436. So I get a nice line like so. Okay, then it asks, part D. Part D, what is the S-intercept? The S-intercept, well, we figured that out because we plugged in 0. That would be 0, 24. And what does that mean? It means that's my starting salary. Okay, so that's what intercepts are used for. Intercepts are going to tell us things about starting salaries, or perhaps later on we'll look at the T-intercept, and that would tell us something important. But in this case, this is the starting salary. 24,000 is starting salary. And finally, part E, when will the person's salary be 42,000? Explain using a graph. All right, so the salary is 42, so here's 39, 36. 42 would be right about here. So they're asking, when will be at 42? Well, if we come across here, come across till we, oh, that's not very straight. Come across straight, so you hit the line right about there, and then go down. It looks like it will happen in about 6 years, so my answer would be 6 years. All right, so that's pretty much what all of your problems are going to look like in this section. You're going to be given a word problem. You're going to build a table. From the table, you'll get an equation. You'll perform your unit analysis. You'll do your graph, and then you'll be asked some questions about the graph.